Welcome back to the deep dive. All right, so today we're diving into some seriously mind-bending stuff. We're talking about the far future of Earth, like way, way out there, a billion years from now. And, based on the research you sent our way, it seems like things could get pretty wild.
Yeah, I mean, when you start talking about timescales like that, it really stretches the imagination. But the science is pretty clear. Earth is a dynamic system, constantly changing. So a billion years, that's a lot of change.
It is. So let's try to unpack some of these potential futures for our planet. And the first one that jumped out at me from the research is, well, it's a bit fiery. A super volcanically active Earth.
Right, and that scenario is all tied to plate tectonics. You know, those giant slabs of Earth crust that are always slowly moving around on top of that molten mantle. Over a billion years, those movements can lead to, well, periods of intense volcanic activity.
Okay, so paint me a picture here. What would a super volcanically active Earth actually look like?
Well, think about it. You could have a hyperactive Pacific Ring of Fire. Imagine constant eruptions spewing lava and ash, reshaping continents, skies choked with ash, the air thick with sulfur, the ground constantly trembling. It'd be a pretty dramatic change.
It sounds intense, almost like something out of I don't know, like an apocalyptic movie or something. But let's shift gears for a second to a totally different scenario. A frozen Earth. Now, this one is connected to something called Milankovitch cycles, am I right?
You are. Milankovitch cycles describe these very subtle changes in Earth's orbit and its tilt. And these changes, even though they're subtle, have actually influenced ice ages in the past.
So how would these cycles play out over a billion years? Could they really push us into another deep freeze?
Well, over such a long time, it's not just a single wobble or tilt. It's more like I guess you could say, a cosmic roulette wheel for climate change. The chances of extended ice ages or warmer periods would increase significantly, even without considering other factors.
So in this scenario, we're talking about massive glaciers covering continents, a frozen expanse stretching out from the poles. But there's one interesting detail in the research that caught my eye. Even in a globally frozen Earth, the equator might actually remain somewhat habitable.
That's right, and it highlights a crucial point about the resilience of life. You know, even in the face of these huge planetary changes, life would likely find a way to adapt and survive in whatever pockets of habitability remain.
Okay, so we've got fire and ice. Now let's talk about the third major possibility, a water world. Now this one seems almost inevitable when you consider the long-term future of our sun.
Absolutely. As our sun gets older, it's slowly becoming more luminous, meaning it's giving off more heat and energy. And that, combined with the melting of any remaining ice caps and the thermal expansion of water as it warms, would lead to a huge rise in sea levels.
We're not just talking about a few feet here. Your sources indicate that sea levels could rise by hundreds of meters. That's almost unimaginable. I mean, what would be left of the continents at that point?
Yeah, hundreds of meters. We're talking about a world where only the highest mountain peaks might survive as tiny islands in a global ocean, a complete transformation of Earth's geography. And it's fascinating to think about what that would mean for life. A potentially thriving marine biosphere, but incredibly challenging conditions for any land-based life.
Wow, okay. So we've got these three incredible scenarios, volcanic, icy, and water world. Each one paints a drastically different picture of Earth's far future. And it really drives home the point that our planet is not static, it's constantly evolving and reshaping itself. But let's shift our focus now. Even if Earth goes through these dramatic changes, will humanity even be around to witness them?
Well, that's the million-dollar question, isn't it? And honestly, your research is pretty clear that the odds aren't exactly in our favor. There are so many potential challenges, both in the near term and far future. And we're not just talking about the obvious stuff like asteroid impacts or supervolcano eruptions. There's even this, well, kind of quirky thing called the decamillennium bug.
The decamillennium bug, what in the world is that?
Well, it's a fascinating example of how our own technology could trip us up. Essentially, it has to do with the potential shift to five-digit year systems around the year 10,000 AD. This could cause compatibility problems with older software that's still being used.
Okay, so not quite an apocalyptic event, but definitely something to think about. It kind of highlights how even seemingly small details can have big consequences when we're talking about such long timescales. But let's move on to some of the bigger threats. One that really stands out is the risk of asteroid impacts. Your research mentioned that kilometer-wide asteroids hit Earth roughly every 100,000 years. That's not exactly comforting.
It's not. I mean, just look at the Chicxulub impact that wiped out the dinosaurs. Over a billion years, the probability of multiple similar impacts is quite high. The question is, will we develop the technology to deflect these threats before they happen?
That's a big if. And then there are supervolcano eruptions, like the Toba eruption about 70,000 years ago.
Yeah.
These are cataclysmic events that can have global consequences, right?
Absolutely. Supervolcano eruptions can spew massive amounts of ash and gases into the atmosphere, triggering significant climate change and potentially leading to mass extinction events. And over 1 billion years, the likelihood of more supervolcano eruptions is, unfortunately, pretty high.
So we've got asteroids and volcanoes to worry about. But even without those catastrophic events, the Earth's surface itself will be constantly reshaping. Your sources mention some pretty interesting examples, like Niagara Falls eroding back to Lake Erie in just 50,000 years.
It's a great example of how even seemingly permanent features on our planet are always changing. And then there's the emergence of the Lucy volcano in Hawaii, potentially forming a new island in a few 100,000 years. It highlights the ongoing process of creation and destruction that's always at work on Earth.
And then there's the really big one, the potential collision of Africa and Eurasia around 50 million years from now.
Yeah.
That's not just reshaping, that's completely remaking continents.
Exactly. These massive continental collisions have happened throughout Earth's history, and they had a profound impact on everything from global climate patterns to the evolution of life. Closing off the Mediterranean Sea and creating massive new mountain ranges would be a truly planet-altering event.
And it's not just Earth itself that will be changing. There are also some fascinating astronomical events to consider. For example, in about 50 million years, Mars's moon Phobos might break up and form a ring system around the planet.
That would be an amazing sight to see. And then there's the possibility of the star Betelgeuse going supernova sometime in the next 100,000 years. That would create an incredibly bright, long-lasting light in our sky.
Okay, but before we get lost in the stars, let's bring it back to Earth. When we look really far into the future, say 250 million years from now, your research mentions the potential formation of another supercontinent, Pangea Ultima.
Right. The continents are in constant motion, and eventually they'll likely come together again to form a new supercontinent. Pangea Ultima would have a huge impact on global climate and ocean currents, leading to major shifts in ecosystems and biodiversity.
And then there's a little bit of a bummer for any future eclipse enthusiasts. In about 600 million years, the moon will have drifted too far away from Earth to create total solar eclipses. No more of those breathtaking moments of totality.
It's a subtle change, but significant. The moon is slowly moving away from Earth due to tidal forces, and eventually those total solar eclipses will become a thing of the past.
And over these vast stretches of time, we have to remember the relentless force of erosion. Even the grandest mountains, like the Rockies, and volcanic islands like Hawaii, will eventually be worn down and disappear.
Erosion is a slow but powerful force. Over hundreds of millions of years, it can reshape entire landscapes, turning mountains into plains and even submerging islands beneath the waves.
But all of these changes, as incredible as they are, pale in comparison to the biggest driver of long-term change, the evolution of the sun itself. Your research highlights that in about 1 billion years, our sun will be about 10% brighter than it is today.
And that might not sound like much, but it has huge consequences for Earth. We're talking about surface temperatures potentially reaching 47 degrees Celsius or 117 Fahrenheit. That's far too hot for most complex life as we know it.
So in essence, 1 billion years from now, Earth could become largely uninhabitable for complex life. Oceans boiling away, a superheated atmosphere. It's a pretty bleak picture.
It's definitely not a welcoming environment for humans or most of the life we see around us today. It's possible that some extremophile microorganisms might survive in very specific niches, but overall, Earth would be a very different and much harsher place.
So does this mean the end of the line for humanity? Or is there a chance we could escape this fate, perhaps through space colonization?
Well, space colonization is definitely a possibility, albeit a very challenging one. Adapting to life on other celestial bodies like Mars or the icy moons of the outer solar system would require incredible technological advancements and potentially even drive significant evolutionary changes in humans. Imagine, humans adapted to the intense radiation on Mars, or humans evolved to live in the low gravity of an icy moon. It's mind-boggling to think about.
It's certainly a long shot, but it's a glimmer of hope in an otherwise pretty grim outlook. And even if we do manage to colonize other worlds, we can't forget about the other cosmic threats lurking out there, like gamma ray bursts or, another devastating asteroid impact.
Those are low probability events, but their potential consequences are enormous. And we also have to consider the very slow but steady lengthening of Earth's day due to tidal interactions with the moon. Over 1 billion years, that could have significant effects on our planet.
So, as we wrap up our deep dive into the far future of Earth, it's clear that we're in for some pretty wild changes. Whether it's a volcanic hellscape, a frozen wasteland, or a planet-spanning ocean, the Earth of 1 billion years from now will be vastly different from the one we know and love today.
It's a reminder that Earth is not static. It's a dynamic system that's always changing and evolving. And while we can't predict the future with certainty, understanding these long-term processes can help us appreciate the incredible journey our planet has been on and the incredible possibilities that lie ahead.
Absolutely. And it really makes you think, doesn't it? Knowing about these potential futures, even 1 billion years out, what does it tell us about our role on Earth today? What kind of legacy do we want to leave behind, whether it's for future humans or for whatever other life forms might inherit this planet? It's a question worth pondering.
It is. It's a perspective that challenges us to think beyond our immediate concerns and consider the grand, unfolding narrative of our planet and its place in the universe.